This is the quarter one factoring project. The objective is for the student to be given practice on factoring polynomials in preparation for Unit 3 quadratics. Unit 3 quadratics requires you to know how to factor, and you also learned how to factor in Algebra 1. So much of this project is a refresher from Algebra 1. The assignment is to complete the notes and activities in this packet regarding factoring. There will be a video and then a page that you'll be completing on your own, and then another video and then another page to complete on your own, and then a third video and then 2 pages to complete on your own. The materials you'll need is this factoring project that's been handed to you, access to YouTube videos, and a pencil. The rules of the project. You must complete all work independently. Your ability to factor will affect future Algebra 2 units. Many of the units in Algebra 2 require you to know how to factor. All work must be neat and legible. Almost all work for this project will be completed outside of class. There will be very few opportunities inside of class to work on the project. You will need access to a graphing calculator or dedicate time outside of class to spend using one in your classroom. You can do this during Wolverine time or after school with your teacher. The project must be turned in no later than October 13th, unless your teacher tells you otherwise. If you have not completed the project by the due date, you are still responsible for the material. As we start Unit 3, you will need the material within this packet. But instead, you will be required to take a factoring test after school. This project is worth a test grade. If it is not completed by the due date, again, you will be required to take a test after school, and you're required to study and know the material from this. This will not be taught in class if you do not complete this project. And again, the test must be taken after school, not during class time before the end of the quarter. This grade counts on the first quarter. Below is the rubric, and it shows you the points for each of the sections. Number 1 will be a video and notes for you to take. Number 3 is a video and notes for you to take. And a small portion of number 5 also has a video. Okay, let's get started. Okay, factoring polynomials, GCF and quadratic trinomials. These are both reviews from Algebra 1. Remember, GCF means greatest common factor. It is the reverse of the distributive property. And you will always check for a GCF, no matter what, when using different factoring methods. GCF is always the first thing that you're going to check for. Okay, let's look at a few examples, even though you should also already know how to do this. So you're looking at, first you're going to look at the numbers. All right, we're looking at 10x squared and 25. So 10 and 25. You need to find a factor of 10 and 25, and you want to find the greatest factor of 10 and 25, which we know in this case would be 5. Then you want to look at the variables. So there is a variable x squared, and there's no variable here, which means that there's no greatest common factor for the variable. So the only thing that we can factor out of this is a 5. So we're going to divide out 5. And then we're going to write on the outside of the parentheses 5. 10x squared divided by 5 is 2x squared. You're going to bring down your sign. And then 25 divided by 5 is 5. So we have 2x squared minus 5. Now, to double check to make sure that you've done this correctly, you can multiply or distribute. So 5 times 2x squared is 10x squared. 5 times 5 is 25. If you get the exact same answer as you did from your original problem, you have done it correctly. Okay, let's look at a little more difficult one. Again, this time we have 3 terms. We're going to look at the numbers first. We have 9, 18, and 6. So you're looking for a factor, and you want the greatest factor. So 9, 18, and 6. Your greatest common factor is going to be 3. I'm going to start there. 3 I know I need to take out. Okay, and now I'm going to look at the variables. Let's start with x. We have 1x here, 2x's here, 1x here. So the greatest common factor is just 1x. Okay, and then we're going to look at the y. There's 1 here, and 3 here. So again, I can only take out 1y. So the greatest common factor is 3xy. Again, we're going to write that on the outside of the parentheses. And then we're going to divide to find out what we have left. So 9xy divided by 3xy is going to be just 3. Bring down our sign. 18 divided by 3 is going to be 6. X squared divided by x is just x. And y divided by y is 1. Okay, bring down our sign again. We have 6 divided by 3 is 2. X divided by x is 1. Y cubed divided by y is y squared. So we factored out our GCF. Just a little side note, if you forget the rules of exponents, when we had the y cubed over y, we simply said y 3 minus 1, so that gives me y squared. If you don't remember how to do this from Algebra 1, you definitely should talk to your teacher or stay after school. Okay, now let's check just to make sure we've done this right. So we're going to distribute this. Okay, 3xy, so 3 times 3 is 9xy. 3xy times 6x, 3 times 6 is 18. X times x is x squared, and then y times 1 is just y. Notice that I'm always bringing down the sign here. 3 times 2 is 6. X times 1 is simply x. Y times y squared is going to be y cubed. So then we're going to check, does this answer match what we started with? Yes, it does. So we did it correctly. So if you're unsure whether you're doing this correctly, you can check to be sure that you have. So there's no reason why you should get these incorrect. Next, we're going to be factoring quadratic trinomials. All right, so let's take a look. There's two different types. We've got a type would have the leading coefficient equal to 1. So the leading coefficient is out here in front. So we know that when there's nothing here, there's really a 1 there. And then a leading coefficient greater than 1. And we can see that because we have that 2 right there, that's greater than 1. So there's the same method, but just a little slight variation when we have the leading coefficient greater than 1. So let's take a look. So we've got the leading coefficient equal to 1. So what you want to do is you want to look at this last term. You want to look at the sign with it. It's negative 14. And then you want to look at this middle term. Negative 5. You want to find numbers that multiply to negative 14 but add up to negative 5. Okay, there's a trick to do this in the calculator. You can sit there and try to find numbers that multiply to negative 14 and add to negative 5. However, if you do have a graphing calculator, there's a trick to do this. So you're going to go from your home screen, you're going to go to y equals, and you're going to type in negative 14 divided by x. And then you're going to press enter and go down to the next line, and you're going to do negative 14 divided by x plus x. Okay? Again, we're taking that negative 14, put in the calculator negative 14 divided by x, and negative 14 divided by x plus x. Then you're going to go into your table. So second graph, what you see here is that you have numbers, this column and this column, they multiply to negative 14. And then column Y2, this is the sum of my column here and the column here. All right, so we know that these two columns multiply to negative 14, but I'm looking in this third column, the y2 column, for negative 5. And I see negative 5 here. So I know negative 7 and 2, negative 7 and 2. Now let's just double check to make sure that the calculator did it correctly. Negative 7 times 2 equals negative 14. Negative 7 plus 2, sorry about that, negative 7 plus 2 equals negative 5. That's exactly what we wanted. Okay. Again, you're going to do that by going into the y equals and doing negative 14 divided by x, negative 14 divided by x plus x. Second graph, the column x and y1 multiply to negative 14, and then the column y2 is the sum of column x and y1. Okay, so now that we found that, we are going to take those two terms, put x's with them, and we're going to use them to replace that middle term. We're replacing the middle term, and we're going to rewrite x squared. So this guy just comes down. We're replacing minus 7x plus 2x, and then we're just bringing this term down, minus 14. And then you're going to group. We're going to group these two together and these two together. And you're going to look for a GCF of these first two terms. So my GCF, if I look, there's no number, so there's no constant that's a GCF. But then I have my variable, I have x squared and x, so I know I can take x out. I'm going to take x out into the front. I'm going to divide out the x here. So that leaves me x minus 7. Okay, and here I've got 2x minus 14. So the only thing I can factor out here is a 2. And notice here, this operation, I'm going to bring that down. So I have 2, and then I have 2x divided by 2 is simply 2. I'm sorry, x. And then 14 divided by 2 is 7. Notice that this is the same as this. So now we're just going to rewrite. We have x minus 7 times, and then you're going to take what's left here on that you factored out, x plus 2. So these are your two factors, x minus 7, x plus 2. Now, if you don't believe me that that worked, or you're not sure that it worked when you did it, you multiply these back together, and you can check to see if you got the correct answer. So we're going to FOIL first. Some of you use the box method, that's fine. So x times x is x squared. Outside, so x times 2x. Inside, negative 7 times x is minus 7x. Last, negative 7 times positive 2 is negative 14. You need to collect your like terms. 2x minus 7x. If you don't know how to do that, that's fine. Then you need to get the calculator out. 2 minus 7 is negative 5. So then we have x squared minus 5 minus 14, which gives us, does this match what we started with up here? It does, so that we know we've done it correctly. So the nice thing about factoring is you could check to make sure that you've done it correctly. Okay, let's take a look at the leading coefficient greater than 1. This process is very similar, there's just one extra step. Okay, now the extra step is you've got to know what to do with that leading coefficient. So we're going to make this extra step here in the beginning. I've got my leading coefficient here of 2, and I'm going to multiply it times the last term, negative 15. So 2 times negative 15 is negative 30. Now, what I'm looking for is numbers that multiply the negative 30, but add to 1. Again, you can do this by hand, trying numbers that multiply to negative 30, but add to positive 1. I'm going to use the calculator. Move it over here. All right, so we've got, so instead of the negative 14, we're using negative 30 this time. So negative 30 divided by x, and then negative 30 divided by x plus x, second graph. All right, again, we've got x, y1. They multiply together to get negative 30. This last column is x plus y1. And remember, we're looking for 1. We're looking for positive 1. So I see negative 1. I don't want negative. I'm going to keep scrolling. Oh, here's positive 1. So negative 5 and 6. Again, if you're not sure, then try it. Negative 5 times 6 is negative 30. That's what we were looking for. And then negative 5 plus 6 is positive 1, which was what we were looking for. Okay? All right, so we're going to use those two, and we are going to replace the middle term. So we're going to take these and we're going to replace this middle term. I'm going to put x's with them. And now we're going to rewrite, because then we're going to group the rest of the processes the same. So we have our first term, 2x squared plus, now we're replacing. Now, notice that it's actually negative 5x, so I'm going to say minus 5x. You're going to use whatever sign is in front of these two. So plus 6x. And then the last term stays. You're not using the negative 30. You're using this last term. So the first term and the last term just get brought down, minus 15. Now we're going to group just like we did down here. Okay? I'm going to put parentheses around the first two terms, parentheses around the second two terms. What can I factor out of here? 2x squared and 5x. Look at the numbers first. 2 and 5, I can't factor anything out. X squared and x, I can factor out an x. So that's going to leave me, on the outside I've got x, and then on the inside, 2x squared divided by x is just 2x. And then 5x divided by x is simply 5. Okay, looking here, we've got 6x minus 15. So I'm going to look at the numbers. 6 and 15, I know I can factor out a 3. There's no variable, so I can't factor anything out there. So I'm going to write, bring the sign down, plus 3. So 6x divided by 3 is 2x. 15 divided by 3 is 5. So again, we're looking to make sure that these are the same. Okay? Those two binomials should be the same in order for you to rewrite. If they're not, then you've done something wrong. Okay? So we have our terms that were the same, 2x minus 5, and then we have what's left on the outside, times x plus 3. So remember, we're looking for two factors here. All right, so those are our two factors, and if you do not trust yourself and you think you've done something wrong, even if you didn't think you do something wrong, it's a good idea to go ahead and check. So we're going to FOIL, or you can use box method, whatever works for you. Do this one a little faster. 2x times x is 2x squared. 2x times 3, 6x. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. We're going to combine our middle term there, and that will give us 2x squared plus x minus 15. check, does this match what we started with? It does, so you know you've done it correctly. Okay, so before we get to that last problem, so what you need to do is you're going to be doing number 1, 2, 3, and 4 that are identical to these type of problems. Now there are going to be a few additional problems, 5, 6, and 7, that are more challenging. Okay, they're a little more open-ended, but you need to get used to seeing different types of factoring problems because there's several ways that these questions can be asked of you. So let's look at what if the question asks you to provide an example of a quadratic trinomial with a leading coefficient not equal to 1. Okay, so basically it's asking you for this piece right here. It's asking you for the quadratic trinomial. What I've asked you so far is to give me the factors. This type of question is actually asking you for the quadratic trinomial. Well, what you want to think about is, well, how do I get to that? Like, can I just put numbers, 3 terms together? Sure. But the trick here is that I want something that I can factor. So the best way to do that is start with the factors. Okay, so let's take a look. So I noticed that down here, again, it says the leading coefficient not equal to 1. So I'm going to need something. I know that my leading coefficient needs to be greater than 1. I'm going to start with these factors. So if I try to mimic these factors, I don't want you to use the same one. We're going to mimic these factors. Okay, so I know I need a number in front of the x. So let's say we're going to do 3x. Okay, so I'm going to, but I want a binomial factor. So let's say 3x plus 2. And then notice that I need another binomial. Okay, but I don't, you could put something in here, but I don't want anything in front of here if I'm going to mimic this type of problem because I know my end result needs to be this trinomial. So let's say I have x minus 1. Okay, so I have my 2 binomials, but again it wants the quadratic trinomial, so I need 3 terms. So what I'm going to do is I'm actually going to FOIL this together. So 3x times 3 is 3x squared. And then I have 3x times negative 1, which is minus 3x. 2 times x is 2x. 2 times negative 1 is negative 2. I'm going to combine these middle terms. So negative 3x plus 2x is negative x. And then 3x squared minus x minus 2. There is my trinomial with a leading coefficient greater than 1. So it's basically requiring you to work backwards. Okay, the key is you want something factorable. Well, if you want something factorable, then you want to start with 2 factors. So let's just practice one more. Let's say that they ask you for a leading, a quadratic trinomial with a leading coefficient equal to 1. Well, let's look at this. So this time I have my 2 binomials, but this time there's no number, there's no leading coefficient there. So I'm going to say, let's say x plus 1, x plus 1. They could be the same factor. So let's say x times x is x squared. X times 1 is x. X times 1 is x. And 1 times 1 is 1. I'm going to combine my 2 middle terms. X squared plus 2x plus 1. This is actually a very special case. This is called a perfect square trinomial, and you will see this actually written as x plus 1 squared. Okay? So whenever it's asking you for a quadratic trinomial, it's the best way to do that would be to find, just make up 2 factors, multiply them together, and that's going to give you your trinomial, your quadratic trinomial. Okay? So again, now on this page, 5, 6, and 7 are a little variation, okay, on the type of problems, are very straightforward problems, but I did a couple examples, so you should be able to do 5, 6, and 7 now.